consider this program, okay? Check if a number is odd or even using bit manipulation. You'll be like, yeah, of course, yes, I know it. Odd or even, if n mod 2 is equal to 0, then it's an even number. If not, it's an odd number. Fine. But the point here is like bit manipulation. But using bit manipulation, how am I supposed to find out if 20 is an even number or not? Alright? So let's have a quick, analyzation of the given question. So given a question, try to analyze it. For instance, let's have 12, okay? 8, 4, 2 and 1. So 8, 9, 10, 11, 12, 0, 0. This is representation of 12 in binary format, alright? So then 13. 13, how am I supposed to represent? 8, 9, 10, 11, 12 plus 1, 13. Fine. Then 14. 8, 9, 10, 11, 12, 13, 14, 0 here. 15. 8, 9, 10, 11, 12, 13, 14, 15. Fine. So suppose that I want to do for 26, then 16, 8, 4, 2, 1. So 26 will be 16 plus 8 plus 16, 24, 25, 26. Alright? 27 is going to be, right? 28 is going to be this. 29 shall be 11101. Alright, so this representation is clear. So now just have a look at this, alright. So if you notice now, rather than looking at everything, just look at the rightmost bits, only up to this to this, and also again here, the rightmost bits. What do you notice here? Do you see some pattern? Don't tell me 0, 1, 0, 1, no. Just look at the number, look at the rightmost bit, alright. So if you notice now, for 12 it is 0, for 14 it is 0 again, okay? So for even numbers it is 0, can I tell that? So similarly 13 and 15 are odd numbers, looking at the rightmost bit. So it is 1, so if at all the rightmost bit is 1, it is odd, okay? Considering the rightmost bit. The rightmost bit is going to be 0, then I am telling you it's even. If it's going to be 1, then it's going to be odd. So let's verify it using these, okay? So like 26 is even, 28 is also even. I look at the rightmost bit, it is 0. So yes, fine. Similarly 27 and 29, I look at the rightmost bits, it's 1 here. So I am telling this is right, okay? So look at the rightmost bit, if it's even, then the rightmost bit must be 0. If it's odd, then the rightmost bit is going to be 1. Fine. So how do I get the rightmost bit? That is the next concern, alright? So in order to get the rightmost bit right, what should I do? Fine. Let's use AND operator. Can you write out using the AND operator? Does something strike your mind? Like how can I use this AND operator? Okay. So suppose that I have 8. Already 8, 4, 2 and 1. So the binary representation is going to be, what is the rightmost bit? The rightmost bit is 0. Alright, so let me AND it, okay? I need the rightmost bit. So what should I AND it with so that I get the value of only the rightmost bit? Can I tell it's 1? Let's see how. Okay, so AND operator, what do you know? Anything AND with 0 will always be what? 0. It will only be true when? If both of this is 1, okay? So no matter what these bits are, I am automatically negating them. Fine? So only this bit shall be considered. So 0, 1 will be 0. Alright, so suppose that if I consider 9, then what happened? 8, 4, 2 and 1, 8, 9. Okay? I added with 1. So all of these bits are not considered. Okay, anything added with 0 is going to be false only, obviously. This is going to be 0. So 1 with 1 shall be 1. Okay. So I am getting only my rightmost bit. 0 with 1, I get 0. Rightmost bit. 1 with 1, I get my rightmost bit is 1. So anything AND with 1 is going to give me what? My rightmost bit. Fine. So I suppose you guys shall now know, right, how to actually solve this. It's going to be pretty much simple now that you know the concept. Okay. So if it all is 20, I'll have to give it even. How? Consider the rightmost bit. So it's not going to return anything. It's simply going to print even, right? Void a function named fun, and they give me the number n. What am I going to do now? I'm telling you that if n and 1 is going to give me what? The rightmost bit. If it is 0, then it simply means it's even. Right? Else, if n mod 1 is equal to 1, then what does it simply mean? It simply means it's odd. See out? That's simple, right? Yeah. So let's look at a more complex question with a similar pattern. Alright?